Okay, good afternoon, everyone. Okay, okay, fine, Anna. Previously, we were in, I think, mm, motion of an object projected obliquely. Okay, yeah, no problem. Right. Yeah, yeah, yeah. By God grace. Okay, record very quickly. No problem. And previously, we discussed about the concept of a body thrown from the ground level, almost to measure. Yeah, yeah, you're right. Good. Good afternoon, Anna. And in that case, most of the models we discussed there. But here, one question related to it. Suppose after projecting the body here from the ground level, of course, it follows one path called parabola that we know. In this case, if they give the initial velocity of projection here and the angle of projection, like the angle of projection, we are taking it as theta, and initial velocity of projection, let it be u. And here, suppose if they ask what will be the velocity here while striking the ground. Okay. While striking the ground, what is the velocity means at that point? Practically, I have to draw a tangent like this. Okay, this will be a tangent here. So this is the velocity. That velocity equals to how much? Okay, if they ask. Means here the question is what I am asking in the projectile motion. Okay, find the final velocity. Good afternoon. Find the final velocity while reaching the ground. Okay, I am not asking after reaching the ground, and after reaching the ground, obviously its velocity becomes zero. While reaching, before striking the ground, what will be its velocity? Okay, nothing to worry here. Why? Because velocity at any point, okay, we know that is v bar equals to like vector form is vx I cap plus vy j cap. And here where vx is equals to, I think you remembered, that is u cos theta if I'm not wrong, and vy equals to, that is u sine theta minus gt. Are the two correct, Anna? Both are? Yes, correct. Both are correct. So Vx, anywhere it is u cos theta time independent. Okay, so here the horizontal component of velocity, if they ask, then straight away we say, sir, here at this point, the horizontal component of velocity, Vx is equals to, we write this is u cos theta, sir, over. Okay. Vy means that is a time dependent, Nana. Time. Okay. No problem, Nana. Okay. And time dependent, here to there to come, I think the time taken is called as total time of flight. Okay. So here, can I write that the total time of flight, okay, try to recollect now, total time of flight is equals to, I think it is 2u sine theta by g. Good afternoon. 2u sine theta by g. Yes, correct. Okay. In that time, what will be Vy? I'm going to find out. Okay, see here. Vy equals to, that implies Vy equals to, feeling well, Nana. I think you are iPhone. Okay, Vy equals to, yes. U sine theta minus G into T. Okay, so see here, I think Lakshmi Sujata opened the video. Maybe it's some network issue. Okay, right. Vy is equal to U sine theta minus here. Okay. G into time, Nana. Time I'm going to substitute here. How much? 2u sine theta by g. In the total time of flight, what is the vertical component of velocity? I'm finding out. Okay. So here if you see gg get cancelled and you are getting there u sine theta minus 2u sine theta. Look at here. If you take u sine theta common, you may get here 1 minus 2. Am I right? So Vy is equals to, you are getting 1 minus 2 is minus 1. So it will be minus u sine theta. Okay. Clearly it is indicating that, how can you say it is 1 meter per second? Nana? Who gave here the numericals for you? I think I did not give any numericals for it. Okay. Yes. Good. So if you see here without numericals, Vy I got minus means opposite direction to initial vertical velocity I got downwards. Yes, minus. And its magnitude is, I am getting here u sine theta. Okay. And here what finally he is asking, what is the final velocity? Over. That implies, finally we write here, the final velocity V bar equals to Vx I cap, that is u cos theta I cap, plus Vy. Okay. Vy is minus u sine theta into j cap. Okay. This is final velocity. And here, if you take the magnitude, you can find one point here, that is root of Vx square plus Vy square. Magnitude is, I think you remember. Why? Because all of you revised all the formula yesterday. Hopefully. Okay. Of course, it may not be the trust. Hopefully, you revised all the formula. Good. Here, so root of Vx square plus Vy square means u square cos square theta plus Vy square whole square, that becomes plus, that becomes u. Good. U square sine square theta. Okay. So if I take u square common here, cos square theta plus sine square theta is 1. So that I am getting u. Okay. Right. I did not take any class, Nana, yesterday. Okay, just I said to revise all the formulae. So that's what I told. You revised all the formulae, hopefully. Yeah. So this is the velocity, Nana. Means again we found that the velocity with which it strikes the ground is equal to u, same velocity. But here only one thing changed. Vertical component of velocity direction is reversed. Okay. Initially the two velocities you will get like this, Nana. Horizontal component of velocity you will get like this. And vertical component of velocity you will get like this. Okay. So initially it is u cos theta. Finally also you got in the same direction and same magnitude. Initial vertical component means I am saying this is ux not vx and this is uy not vy is equals to u sine theta. But look at here uy and vy. Magnitudes same but direction I got opposite. Okay. Not minus u, Nana. Why? Because the velocity is not coming in opposite direction to it. Okay. Magnitude, you can say u, right? Since the two magnitudes are equal, horizontal and vertical, you may say that here it strikes the ground with what angle? Okay. Say suppose alpha, you can prove that that is equals to theta. Okay, using the formula tan alpha is equals to opposite side, that is Vy, if I complete it as a parallelogram or rectangle or square here. Tan alpha is equals to opposite side Vy by adjacent side, that is Vx. So Vy and Vx, both the magnitudes, if I substitute there, I will get u sine theta divided by Vx is u cos theta. So here what I'm getting, tan alpha is equal to, by cancelling u and u there, you will get tan theta. That implies alpha is equals to theta. So you may say that here, what, it strikes the ground with the same velocity, it strikes the ground with the same angle, but only vertical component of velocity will be changed. That's it. The rest of the things is same. Yes. So all of you understood here what I told, Nana, about the final velocity? Sure. Okay, good. Who will be changed? Is it a horizontal component or vertical component? Just no one is changed. Just the direction of vertical component is changed. Yes, that is correct. Vertical component, that only direction is changed. Yes, good. Okay. Rest of the things same. Same magnitude of velocity, same angle, same horizontal component, same vertical component, but direction is reversed in vertical component. Okay, Nana? Right. Now, look at my question related to this concept. I am moving to next page. Here, in the second page, related to the question, related to the, sorry, concept, I am giving one example. Okay. In case of oblique projection, okay, find the change in velocity in total time of flight. Change in velocity in total time of flight. Okay. I am asking what is the change in velocity in total time of flight. Initial is u, final is u. Can I say u minus u 0? Mr. Amok, you fell in my trap. Even this is also wrong, Mr. Amok. No, sure, Lakshmi Gayatri. Is it not 0? No, okay. Yes, yes, sir, it is not 0. Yeah. Okay. U sine theta. Where is Yamra, Mr. iPhone? Sine theta, sir. Okay. Right, sure. In the next page, nothing is there, Nana. Simple, I gave the question. What is the change in velocity in the total time of flight? Okay, I think even though it is wrong. I am not asking the change in speed, Nana. I am asking change in velocity. Change in velocity. Velocity means better you go with vector form. Why? Because velocity is a vector. No, that is also wrong. Better you write in I and j cap form. You will get the answer very easily. Initial velocity and final velocity. You will get very easily the answer in just 2 steps. Okay. If you are not getting any idea, just see here. Final velocity means generally we write it as Vx I cap plus Vy j cap. Okay. That is u into Vx. This is not final answer, Nana. Vx I cap plus Vy j cap. Okay. See there. Vx is u cos theta I cap plus Vy is minus u sin theta j cap. In the previous page, we got that. Okay. Vy is minus u sin theta. Vy j cap. Okay. Clearly, I wrote here u cos theta I cap minus u sin theta j cap. Yes, correct. And initial velocity in the same way we write it as u bar equals to ux I cap plus uy j cap. Okay. Ux is again u cos theta I cap. Uy is plus u sin theta j cap. That's it. You can see ux and uy here. Uy is along positive y axis. Yeah. Now you are coming to the point. Okay. So here, if I subtract these two, v bar minus u bar, he is asking what is the change in velocity. Okay. If I subtract, then I will get in the next step, v bar minus u bar is equals to, yes. If I subtract, these two get cancelled, Nana. This positive also becomes minus. Yeah, right. Minus u sin theta minus u sin theta is minus 2u sin theta j cap. Okay, that is nothing but 2u sin theta is the magnitude into minus j cap is the direction. So this is v bar minus u bar. Okay, if they ask what is the magnitude of v bar minus u bar, magnitude of change in velocity, then out of these two, who is the magnitude? Is it j cap or 2u sin theta? Right. 2u sin theta is the magnitude. Minus j cap is the direction. So here the magnitude is 2u sin theta. And if they ask direction, you can say that it is along minus j cap means along. Can I write here negative y axis, Nana? Minus j cap means along negative y axis. Is it correct? Both magnitude and direction. Yes, correct. Good. This is the change in velocity, Nana. Okay. This was given previously in exam with some numerical values. Okay. Just what he gave, if you know the formula, the change in velocity is 2u sine theta and its direction is along negative y-axis. So without using pen and paper, we can say the answer. Okay. Yeah. Okay, no problem, Nana. No problem. Yeah, it's okay. So if you see here, the previous question, okay, a body is projected obliquely at an angle 60 degrees with the better. Every time we are taking angle with the horizontal. This time I'm changing at an angle 30 degrees with the vertical. Okay, with the vertical, comma, with a velocity of 10 meters per second. Okay, find the magnitude of change in velocity. Okay, see here how many will give very quick response. Yeah, 10. Yeah, correct. Yeah, very good, very good. I think given 30 degrees sine 30 is 1 by 2, Nana. Is it not correct? Yeah, 60 degrees. Why it is 60 degrees? Yeah, right. He gave the angle 30 degrees with the vertical. Okay. Yeah, we measure with the horizontal. Good. So here in the solution, don't take theta is equal to 30 degrees, Nana. Yes, with the horizontal theta is equals to 90 minus 30, that equals to 60 degrees. Right. Good. Then simple, just substituting the two values there in the formula to use sine theta. You will get the answer. You already got the answer, of course. That is 2, u is 10 given here. Okay. Angle is not 30, that is 60 degrees. That is sine 60. Yeah, sine 60 is root 3 by 2. 2 get cancelled. You will get here 10 root 3 meters per second. As the angle to the horizontal is to be considered. Yes, correct only, Nana. That's why we have to take 60 degrees. Yeah, 10 root 3 correct only. Okay. 45 root 3. Super. You are super. Okay. Then next question here. Okay. Then here, suppose if I give one question. In the above example, means same thing. Initial velocity of projection u is equals to 10 meters per second. Theta is 60 degrees. Same. In the above example, find the change in velocity, of course, magnitude. Find the magnitude of change in velocity. Sorry. Change in velocity in the time of ascent, not total time of flight. In the time of ascent. In this case, Nana, do you have any idea for this question? Time of ascent. T is T by 2. Yes, correct. Is it 10? Is it correctly? I am not asking the velocity at highest point, Anna. Change in velocity. Okay, we'll see here. Oh God, all of you are typing different answers, but they are not correct. Okay. I think U bar, you don't have any doubt, Nana. That is U cos theta I cap and U sin theta j cap. Okay. But I think in total time, sorry, in the time of Sn, U sin theta by 2. Right, U sin theta by 2 or U sin theta by G, Nara? Time of Sn? What that? It is U sin theta by G, Nana, not 2. Array, all of you revised properly, Abba. Yesterday, right, good. In the time of Sn, okay, okay. That's why I told revise once. Okay. What you put in your WhatsApp group, Mr. Manikanta, yesterday? Many times I revised. Okay. Yes, many times he revised, but telling that the time of ascent is equal to u sin theta by 2. Okay. The time of ascent, that is TA is equals to u sin theta by g. Vertical component and horizontal component already we measured both, Nana. Vy equals to 0 we got, and Vx is equals to, that is common, u cos theta all the times. Okay, previously already we solved. Okay, so final velocity V bar equals to, we write Vx I cap, that is u cos theta I cap, plus Vy j cap. Here we are getting 0 j cap. Now I think you will get some idea. Initial velocity, this is common. U cos theta I cap plus u sin theta j cap. Ux I cap plus Uy j cap. So here again I am taking what is the change in velocity. Okay, so change in velocity I am getting here Vx, sorry, V bar minus U bar is equals to, cancel, Nana, 0 minus, that is minus u sin theta into j cap. Yeah, right. So you are getting, this is u sin theta into minus j cap. So who is the magnitude here? Is it u sin theta or minus j cap? Now it is correct. Yes. Right. Okay. U is 10. Sin theta. Ishan also top, Papa. Okay. Minus j cap is direction, Ishan, not the magnitude. Okay. U sin theta. This is sin 60. So you will get, this is 10 into root 3 by 2. Okay, right. This is equals to 5 root 3 meters per second. So now is it clear? Okay. Yes, sir. Crystal clear. Okay, right. No. Which is no? Yes. Clear or not clear? Yeah, good. Some is clear. Okay, good. Right. Then here, Already we solved many models related to this oblique projection from the ground level, Nana. Okay. So better, I think it is the time to move exactly at 3:30 to move to another concept. Okay. So I'm moving to another concept here. Yeah. Ah, really? Ayayyo, ayayyo. Ah, right. Here, moving to another concept. Yeah, already I mentioned you, now. No need to change. So another concept here is not circular motion. Here only projection, but not from the ground level, but from the top of the building. Okay, like the concept is projection from the top of a tower, from the top level, from the top of a tower. Okay, Nana? In this projection, just we are going to discuss the first model. Okay, number one. Here, what is that, sir? Not new chapter. After completing all these things, we will go to new chapter. Okay, nearly it may take 3 to 4 days. Okay. Right. Here, in that first model is projecting horizontally from this top of tower. Okay. Fine, Nana. And here you observe how you are projecting and what are the things related to it. You take it as top of tower of height h. Okay, its a height is h. There to here. Take it as h. And you are projecting from the top, standing on the floor of the roof of the building and projecting horizontally with a velocity u. Can anybody say here when I project horizontally from the top of a tower by taking here this is x-axis, that is my Vishnana. I can change the coordinate axis. So this is x-axis and this time I'm taking it is y-axis. Okay, which one? This one I am taking it as y-axis. Okay, this is my convention. It is x-axis and it is y-axis. Okay, means this is taken as, don't say negative y-axis. I am taking it as positive y-axis. This is positive x-axis. Okay, will you say answer to my first question here? What will be the angle of projection, please? Will you anyone please tell angle of projection? What with x-axis badudai? Angle of projection with x-axis. 0. Why? Because you projected along the x-axis only. Okay. Along the x-axis means angle of projection theta here equals to 0 degrees with x-axis. Yeah, maybe 0 or double 0. Okay, good. If theta is equals to 0, will you say that initial velocity is none? Along x-axis, what is the initial velocity? Along y-axis, what is the initial velocity? You know, previously this is u cos theta and this is u sin theta. Ah, very good. U cos 0 is 1. Very good. Nice. That is, yeah, good. Correct. U along x-axis. Sine 0 is 0. 0 into u is 0. That is 0 along y-axis. Very good. Very good. Very good. And acceleration due to gravity acts in what direction, Nana? G. After projecting, it is coming into air. Air, it experiences only, very good, downwards. Acceleration due to gravity. So acceleration due to gravity downwards. This is G, the acceleration of the particle. So acceleration is along y-axis means ax is how much, ay is how much, along x-axis how much, along y-axis how much. Are you getting any component along y-axis? Very good, very good, very good. Amog, I think you did not mention the sign properly, Nana. Look at my y-axis. Downward is my y-axis, not upwards. Downward is my positive y-axis. Array. All of you typing wrongly, Nana. Downward is positive y-axis. Now it is correct. Positive y-axis means along y-axis, this is a plus g. Okay, clearly I mentioned this is positive y-axis. So g is along positive y-axis only. Positive y-axis means ay is equals to plus g according to my convention, coordinate system here. And along x-axis, do you have any component, Nana? No, very good. That is 0. Very good. Ax is equals to 0 along x-axis, ay equals to plus g. Okay, right. Now I am asking after certain time, okay, here what will be the displacement along x-axis and y-axis? Okay, the displacement along x and y axis or displacements are after certain time you are saying, okay, are in terms of t. Okay, as you wish, in terms of time. Okay, y is ht, height of the tower. No. Somewhere in the middle I am asking. Somewhere in the middle I am asking where y is equals to half gt. Who is this Amog? Means yesterday he, now it is correct. Badudai. Half gt square. Very good. X is right. Both are correct. Right. Amog responded, Nana. What about others? I'm asking displacement means x is equals to or y equals to, I'm going to use s is equals to ut plus half at square. Okay. If I write here in a table, you can understand very easily. Along x-axis and along y-axis. Now you say very easily. Along x-axis, u is equals to, in the previous page we wrote it as u only along x-axis, and along y-axis in the previous page you wrote it as 0. You can check it there. Ux is equals to uy and is equals to 0, and accelerations you wrote 0 and g. So here I am writing ax is equals to 0, ay is equals to g. I'm asking what is the displacement along x-axis? That is, x is equals to how much? Displacement along y-axis. Yes, y. Let it be y. How much? Okay. after in terms of time. So after a time t. So you are going to use what? S is equals to ut plus half a t square. Very good. I think someone posted here. I will see that. Check what is the answer. That is the formula. Ut plus half a t square. Then what is x and y? Okay. Along both the axes. No need to wait. That will be easy. Very good. Correct only Gayatri. Lakshmi Gayatri. Right? Yeah, this is x. What about y? Good. Half GTs. Right. Good. Today I'm seeing very poor response from you all. Okay, okay. I understood now. Only from 2 students I got the answer. Tanisha. Yes, correct. Good. 3 students. That's all. Oh. I think it may be the Saturday's effect. Okay, no problem. I will do. Along x-axis. Correct. Y is correct. X. Not bad. Good. So along x-axis, if I substitute Sx, that is x is equals to, along x-axis, I will get here u is u only, into t is t only, in that plus half, a is 0, Nana. A is 0 means this part becomes 0 along x-axis. So I got x is equals to ut over. And same equation along y-axis, if I write here, s is y equals to u. U is 0 along y-axis. So 0 into t becomes 0 plus, half a is g into t square. That's it. So x is equals to ut, y is equals to half gt square. There are the 2 displacements along y and x-axis. Okay. Now, being an intelligent student, of course, all of you are intelligent students. That's why it may be your question, okay, trying to throw on my face. What, sir, here, why you derived all these things, sir, in the previous one projected from the ground level? As we know, we means excluding me, all of you. As we know, sir, x is equals to, I already derived u cos theta into t in the previous part, sir. All of you are very intelligent. Okay. And y is equals to u sine theta into t minus half gt square. Okay. By taking upward as positive y-axis, sir. But this time you took downward as positive y-axis, sir. So just I change the sign, sir. This is plus. Okay. And theta I put 0, sir. Okay. In this case, projected horizontally from the top of a tower means, here I already told, theta equals to 0. I will get the answer in one step over. Okay. And theta equals to 0. We will get, sir, x is equals to, by putting theta 0, cos 0 is not 0, it is 1, u into t. Same you derived in the lengthy procedure, sir. Okay. And y is equals to, sir, theta 0. So this whole thing becomes 0, sir. 0 plus half g t square. Same thing got there. Okay. Okay, no problem, no problem. Okay, good. So see here, you said in just one step, whereas being not an intelligent master, I explained in a long way. Okay. So in this case, please excuse me. Okay. At least one time you try to excuse me. All of you excused? Excused or not? No response. Are please excuse me, Ra. Saiwan. Okay, sir. Okay, right. Nothing. Just kidding. Okay, leave it. Right. X is equals to ut and y is equals to we can yeah, understood. Y is equals to half gt square. Right. Okay, now this is x and y. Okay. Okay, no problem. Okay. I have tried to give the justice to it at least. Right. So here, suppose in this case, what in projecting horizontally from the top of a tower, the relation between x and y, similar like y is equals to ax minus bx square, what you got there. Such type of equation will you give from these two, what you got? To get the relation between x and y means simply eliminate t nana from the two equations. In just, I think, one step, you will get the answer. By putting t is equals to x by u here, okay, is dash. If I ask just in one or two steps, you can say t is equals to x by u, sir. That implies y is equals to, you can write half g t square. In this equation, I am going to substitute t is equal to x by u from the first equation, sir. Then I will get a half g t square means x square by u square. Okay. So see here. Good. X square by u square. That's it. You are getting y is equals to some constant. What half g by u square is a constant into x square. Okay. Check there, Nana. All those are constant means I assume it as a or b. That is your wish. Okay. Here I am getting only one constant. So I go with a into x square. Yeah, that implies a, where a is equals to the constant, I got half g by u square. Okay. So look at again this equation, Nana. I got y is equals to ax square. Y is equals to ax square is a perfect equation of a parabola symmetric to y-axis. So again, I am getting here, what is the path of projectile if they ask from the top of a tower? Again, sir, it is a parabola about y-axis, sir. About y-axis, you will get a parabola like this. Yes. So it is a parabola again. Another type of parabola, symmetric to y-axis. Previously, we got symmetric to x-axis. Okay. So here I got a parabola. That's fine. I write here. This implies the path of projectile is a parabola. So understood, Nana, this concept? Projecting from the top of a tower? Or any doubt in the concept? Yes, sir, got it. Okay, then, right. So I'm moving to next page. Okay, good. So in the case projecting from the top of a tower, what the equations I got? One is x is equals to ut, other is y is equals to half gt square. Third one is y is equals to ax square, where a is equals to half g by u square. That's it. Okay. These were the equations what we got in the previous pages in case of a body projected from the top of a tower. Yeah. Related to them, I will ask the questions now. Okay. Now, the question is here, suppose you take it, this is the top of the tower. Okay. And you are projecting from the top of a tower a body like this horizontally. Okay. And of course, you know the path. It is a parabola like this. Path of a projectile is a parabola. You may get a parabola like this. Okay. And suppose this is the ground here. This is the ground. I think after projecting, it may hit the ground somewhere here. Okay. Question is, before hitting the ground, one, what is the velocity? That I will find out later. Here, from the point of projection, means from the level of point of projection, what is the horizontal distance traveled? Okay, horizontal, maximum horizontal distance traveled already we defined in the previous concept, that is called as range, Nana. So this is the range, or is the range equals to how much? First question. And from there to here to come to the ground, what is the time taken? Where t is called the time of flight. Okay. Suppose if you want to represent that one with the capital T, that is your wish, Nana. You can represent with the capital T. Okay. Right. So come to here. How to find the time of flight? How to find the range? And keep in mind, you know the height of tower. Don't forget. You know this height as h. That you know. Okay. This is h. So look at here. 10. How you get that is 10, Nana? There are no numerical values here now. Time of flight equals to how much? Yeah. Okay. Take the initial velocity as u. Okay. No problem. Simple, Nana. Nothing to worry here. H is the vertical displacement or horizontal displacement? Vertical. So vertical displacement, already you know the formula, na? Why don't you use this formula here? Okay. So as we know, y is equals to half gt square. So in this case, while reaching the ground, vertically traveled a displacement of h sir. So y is equals to h sir. That implies h is equals to half gt square sir. So I got the second answer for the second question. Over. So cross multiplication, that implies 2h by g, right, equals to t square, sir. Therefore, time of flight, which is t, is equals to, I'm getting the answer, root of 2h by g. That's it, over. This is the time of flight. Okay. And in the same way, I think you can calculate the range also. Look at here, range is appeared to be along x-axis or y-axis. along x-axis. Over along x-axis, you know the formula, u into t. So use that formula. As we know, x is equals to ut. Here I am asking that x range, that x is equals to r. In how much time? In the time of flight. X is equals to r and t is equals to time of flight, root of 2h by g. Over, substitute the two values there, you will get the answer. Yeah, that is correct only, Amok. Okay. Therefore, just one step only. That implies x is r equals to u into, in that time of flight, t is equals to root of 2h by g. That's it. This is the range. Over. Okay. And if they ask in the same question, here, while reaching the ground, suppose one person stood here and catch that ball which is thrown from the top of a tower with a horizontal velocity u. Okay. And immediately seeing the roof, the angle of elevation here, if they ask, angle of elevation means like this. Look at here. This is the angle of elevation. Okay. Angle of elevation with the horizontal over. Suppose you take it as some phi. That is better. Okay. I am asking next one. The angle of elevation. Okay. Phi equals to how much? Tan inverse h by g, Nathalie. Right. This is correct. Correct. Right. You are using, I think, right angle triangle tan phi. Okay. So here, angle of elevation, directly you can say, right? Tan phi from the figure, we can say what tan phi is equals to opposite side by adjacent side, h by r. That implies phi is equals to tan inverse h by r. Okay, very good, very good. And in the same question, if I ask at some point here, suppose this is the point A, it is the point B, and at some point C, if I ask what is the velocity of the body? Okay, if you have any doubt, you can use those formula what you buttified yesterday. If you buttified, of course, conditions apply. Okay, here the velocity, next question I am asking, what is the velocity, okay, at C after a time t? Okay, is very simple. Very simple. You can easily get that. Vx and Vy, if you remember in the previous one. Vx is u cos theta in the previous concept, and u sin theta minus gt. But downward is taken as positive y-axis. So this is plus gt. Until here, you understood Nana concept? Or do you have any doubt in this? Do you have any doubt? No doubt. So here, simple. The theta angle of projection in this case, how much? As we know, theta equals to. Yes, theta equals to. Quickly. Angle of projection, 0, correct. Theta equals to 0 degrees. Therefore, over, yeah, Vx is equals to, you got, u cos theta means u cos 0 is 1, Very good. And Vy is equals to u sine theta, sine 0, 0. So 0 plus, I am getting how much, Nana? G into T. Okay. If I ask, yes, good, vector form V bar, then what do you say? Vx I cap plus Vy j cap. Okay. That is equals to, I write it as U I cap plus Vy is Gt j cap. Okay. And if I ask, what is the magnitude of velocity? That is root of Vx square plus Vy square. Okay. Vx, you already typed here. It is there in your typing. Vx, or else you can see here. Vx is U. Vy is equals to Gt. Yeah. I understood, Nana. Root of Vx square is U square plus Vy is Gt whole square. That equals to root of U square plus G square T square. Okay. And here, what is the angle made with x-axis here? That velocity. Okay. This velocity with x-axis makes how much angle? Alpha. That one also in the previous concept I told. Tan alpha is equals to Vy by Vx. So simply you can say, as we know. Okay. Yeah, tan alpha. Alpha is not theta, Nana. Why? Because tan alpha is equals to how much you get there? Vy. Vy is Gt, Nana. Gt by Vx is U. Yeah, correct. Vx is U. That implies alpha is equals to, you are getting tan inverse Gt by U. Okay. This is alpha now. So these are the formulae related to velocity concept. Alpha, magnitude of velocity here. Okay. And in the previous page, what is the vector form of it? Okay. And what are Vx and Vy values? Okay. And here angle of elevation, phi is equals to. These were few formulae related to the concept we discussed today. So all the things clear, Nana, here? Or do you have any doubt in the concepts? Right, good. So here I'm going to wind up the class. Okay, have a nice weekend. Okay, sure. This is, I think, first page, Nana. This is the first page. Thank you. Thank you, Nana. This is second page. Thank you all. This is the third page. Thank you. Thank you. This is the fourth page. Yeah. This is the fifth page. Right, thank you. And this is the last page. Okay. So shall I stop sharing? Okay, right. Bye, Nana. Bye, everyone.